Hello everyone, now we would like to learn about the specific heat capacity. This is the learning objective. Now, we will start with discussion like this. In some Korean cuisine, they put the food inside the bowl made of the stone. Actually, there is a purpose for this one. They thought that it's gonna be warmer. But why is that? I give you 1 minute to think about the reason. Okay, time is up. Now, this is another question. You know, during the day, desert temperature rise to an average of 38 degrees Celsius. Yes, this is actually higher than the human temperature because the average of the human temperature is 36 degrees Celsius. And amazingly, surprisingly, at night, desert temperature fall to an average of minus 3.9 degrees Celsius, which is this is lower or colder than the average temperature in Bandung. Again, why is that? Okay, to answer those two questions, we have to talk about this one first. It's thermal capacity, or another name is heat capacity. The definition of the thermal capacity basically how many thermal energy used to change the temperature of an object by 1 degree Celsius. Now we have two objects here. The first one is wooden bar, that is the heat capacity, 200 joule per degree Celsius. The second one is soap liquid. The heat capacity is 50 joule per degree Celsius. What does it mean with the heat capacity 200 joule per degree Celsius? It means a wooden bar needs 200 joule to change its temperature by 1 degree. Change temperature here means to make it hotter, to make it colder by 1 degree Celsius. What about the soap liquid? With the same pattern of definition, this is the definition of the heat capacity of the soap liquid. Now, you can compare. For the wooden bar, to change temperature, it needs 200 joule. But for the soap liquid, it's only 50 joule. Now, which one will be hot fastest? Soap liquid. Because what happened? It needs less energy. Only 50 joule to change its temperature compared to the wooden bar, 200 joule. Next question, which one will be cold faster then? Okay, remember if it is hot or heating, it receives the heat, right? If it is cooling down, it means release the heat. That means who will change temperature faster? It's gonna be soap liquid because it lost less energy based on the heat capacity to change its temperature. If you have any question, later you can ask me. Next, now based on the definition, you can make a formula for the heat capacity. The heat capacity symbol is capital C. Remember, it's supposed to be capital because later the small c has different meaning. It's equal to Q divided by delta T. What is Q? Q is quantity of the heat. Heat is energy, that's why the unit is joule. C is the capital for the thermal capacity, that is joule per degree Celsius. Delta T, T here is the time, T here is capital, time small t, this one capital T, it's temperature, and delta means change, so delta T means the change or the difference in temperature. Since the thermal capacity is in joule per degree Celsius, this one, so the temperature must be in degree Celsius. If you change, or if you don't know what's the delta T, just final minus initial. Okay, now from this equation also what happened? You can find the Q. Change the position, the Q will be C divided by T. To make it easier to remember, I change it into, what is it? Cube cap. Cube cap. That is Q equal to C delta T. Now, how do we use the formula? This one. Okay, I'm gonna give you time 10 seconds to read the question. Okay, from here we can get some information. 25 degrees Celsius, that is the initial temperature, and the thermal capacity 200 joule per degree Celsius, and the final one is 50 degrees Celsius. To find the thermal energy, that's the Q, you have to find the delta T first. So that is delta T, and the Q using this equation, cube cap, and that's the answer. Again, if you have an equation, later you can ask me, but if you want to repeat my explanation, you can replay. Now, the next question, I give you 10 seconds to read the question. Okay, from here we got the heat capacity 50 joule per degree Celsius. We have the delta T. Why we have the delta T suddenly? Be careful. When there is the word by and then temperature, that means by that temperature means delta T, the change in temperature. So since the word is by 50 degrees Celsius, delta T is 50 degrees Celsius. Then you have to find the Q, right? The Q will be C80. So that is the thermal energy. Now, remember I said before, for the thermal energy you have to use the capital C, because the small c has different name. It is specific heat capacity. Please read the definition. You may be wondered, the definition is quite similar with the thermal capacity. What's the difference? This one. In here you have to make sure the mass is 1 kilogram. If it is not 1 kilogram, that is not specific heat capacity. Example, look at this one. What is SHC, sir? This is the abbreviation from the specific heat capacity. So for the water, that's the number. Aluminium, that's the number. For the ice, that's the number. What does it mean? Okay, it means like this. 1 kilogram of water needs how many joule? Based on this number, it's 4,200 joule to change its temperature by 1 degree Celsius. See, in this definition, you really have to talk about the kilogram, the mass. Now, with the same pattern, what can you write for aluminium and the ice? Okay, I'm gonna give you like 10 seconds to make your own sentences. Okay, cool. This is it. What can you see? The pattern is the same. The mass is 1 kilogram, but the difference here is only the materials and the number of the energy. Cool, let's go. Now, we have the same substance actually. It's water in liquid on the left, and the water in the solid. It's the ice. You can see the difference in the number of the specific heat capacity. Now, what is it? Which one will be change its temperature by 5 degrees Celsius faster? Like in the thermal energy, the smallest one will increase faster, right? So in here, it is the ice. Now, next question. Why ice have lower specific heat capacity than the water? Okay, think about the state. Ice is solid, water is liquid. Think about the bonding force. solid is stronger than the liquid. So what happened? Ice is a solid. Distance between the particles are closer than those in water. So what happened? If you give energy to the particle of the solid, it's gonna vibrate, right? So it's gonna be transferring energy to vibration. It's gonna be fast because they are closer. But in water, it's far, so it's quite difficult to transfer the heat to other particle. Any question? You can ask me later. Okay, let's go back into the bibimbap. Now, if you compare the specific heat capacity of the stone, that is the 840, for the ceramics, it's smaller. So what does it mean? Which one will be colder faster? This one with the smaller specific heat capacity. So ceramic, because it releases less energy. That means what happened? In the bowl, the rate of cooling down is less because it needs longer time to be cold. That's why the reason why Korean people, some of them, use the stone bowl for some of their cuisine. Okay, what about in the desert? Okay, in the desert, as you can see, dominantly we have two substances. The first one is the sand, the second one is the air. In the city, like in Bandung, we have many materials. We have land, we have water paver because it is humid. We have wood from the tree or maybe the building, and the stone from the building or from the ground. What happened now? Most desert only has sand. No other object can absorb or keep the heat. That's why it's gonna be really heat fast because all absorbed by the sand and air only. And then what happened? It's gonna be cool down fast because nothing else that can keep the heat compared to the town. Okay, now for the specific heat capacity from the definition also, we can use the equation. C equal to Qm divided by M times delta T. It's looked like similar with the thermal capacity, right? But in here, the difference is, what's that? We have mass on the bottom. And in here, the specific heat capacity will be different. The unit will be different compared to the thermal capacity. Okay, now what happens? If you have the unit in joule per kilogram degree Celsius, it's actually the same with the joule per kilogram Kelvin. So you don't need to convert because they are the same. This is the equation if you want to find the Q. Q equal to mc delta T. For here, to make it easier, the Q is equal to my cat. Remember, if it is specific heat capacity, Q equal to my cat. Next, this is the example question. I want you to read the question in 10 seconds. Okay, let's start. What happened? We have 2 kilogram, that's the mass. And then we have initial temperature 20. And then we have the final temperature 60 degrees Celsius. The C, remember, it's specific heat capacity, right? So it's C. That is joule per kilogram degree Celsius. Before we continue, make sure the unit is the same. Look at the specific heat capacity unit. It's in kilogram. We have the mass in kilogram. And we have degree Celsius also. So, no need to convert. You have to find the delta T. That is the delta T. And the Q is my cat. Submit everything. That's the thermal energy. The next question. Please 10 seconds to read the question. Okay, let's go. So we have the mass 5 kilogram. Why we have to convert into gram? Look at the specific heat capacity unit. In here it's per gram. So that's why you have to use the gram. Initial is 25. That is the specific heat capacity, and the Q is 10 joule. What should you do actually? Final temperature, right? So you have to find the change first. After that, you have to add with initial temperature. So this is the delta T. You submit everything. That is the delta T. Okay, now, how do you find the final temperature? Just add. But then, sometimes what happens? The final temperature will be lower, right? Why you have to add it? Why it's higher than the initial one? Because this one, it's heated. If the object is heated, what happens? Temperature will increase. If later the question will be cooled down, of course the final one will be lower than initial. But here, since it is heating, you have to plus it. So 25 plus 15.4, that is the final temperature. That is the end of the explanation.